Good morning once more. Welcome to today's class. This day we will discuss two-way ANOVA. Remember, ANOVA means analysis of variance. This video will be in two parts. One, introduction of the topic, and two, calculation under it. What is two-way ANOVA? Why are we studying it? Like other statistical technique we have, two-way ANOVA is another statistical technique we have that is used to study effect of the independent variables on dependent variables. I repeat, two-way ANOVA is a statistical technique that is used to study effect of independent variables on dependent variables. What do we mean by that? If you are to study effect of age and gender in variation in height, if you are to study effect of age and gender upon or in variations in height, it is an example of what? Two-way ANOVA. So if you are studying independent variables, effect of it on dependent variables, you are talking about two-way ANOVA. This two-way ANOVA has a model. The model is made up of Yij equals to overall mean plus AI plus Bj plus random error. Now, this Yij simply means observation taken under height level of factor A and jet level of factor B. So this Yij means observation taken under height level of factor A and jet level of factor B. Then AI simply means height effect of factor A. Bj means jet effect of factor B. Then note that in this model of two-way ANOVA, I is equals to 1, 2, 3 to A. Yj mean or Yj ranges from 1, 2, 3 to B. Okay? So this is another. So this Eij is noted to be random error. Remember, in the first video on this topic, the first video on ANOVA, we realized that while you are trying to analyze a given data given to you, you have to take recognizance of error, because you are not perfect, so you can encounter error while analyzing. So we must take recognizance of error. So this is simple model of what? Two-way ANOVA. Now, two-way ANOVA has its assumption. It has three assumptions. Assumptions of two-way ANOVA. 1. Normality. 2. Constant variance. And 3. Independence. So these are the three assumptions of two-way ANOVA. So it has the same assumption like one-way ANOVA. Then this two-way ANOVA has a table. It is called two-way ANOVA table. So what does it contain? In two-way ANOVA table, it is drawn this way. Yes, the first one is called source of variation. The next one is called degree of freedom. The next one is called sum of squares. Next one is called mean of squares and Fishner F ratio. Remember I said this F ratio is gotten from a scientist named called Fishner. Then you say factor A is first source of variation we have. Factor A, you have A minus 1. You have factor B. Factor B, you have B minus 1. Then error, you have A minus 1 bracket B minus 1. Then total, this plus this will be giving you AB minus 1. So you underline. Okay, what are the sum of squares? Sum of squares for this will be sum of squares of factor A. Sum of squares of factor B. Sum of squares of error. And sum of squares of total. Okay? Then this will be mean of squares of factor A. Mean of squares of factor B. Mean of squares of error. Okay? Then, what is F ratio? Whenever you are discussing two-way ANOVA, from the name two-way ANOVA, two-way ANOVA. So, it means that you have two conclusions from your results. So, in this, we'll say, okay, here is MS factor A all over MS error. MS factor B all over MS error. So you will use this for your first conclusion and use this for your second conclusion. Okay? Then, after you must have written this is called two-way ANOVA table. Two-way ANOVA table. Okay? Then, now, after you have written this, your test statistics will be check if F calculated for the first one is greater than F gotten from your table. Check again if F calculated for the second one, this is first one, this second one is greater than F table. If F calculated is greater than F table, you say reject null hypothesis as a conclusion. But if F calculated is not greater than F table, say accept null hypothesis. So reject null hypothesis, otherwise accept. What we mean by otherwise accept means if this calculated, F calculated is greater than F table, say reject null hypothesis. But if F calculated is not greater than F table, say accept null hypothesis. That is what we mean by otherwise accept. Also, that same thing applies this, reject null hypothesis, otherwise accept. Okay? That is it. Now, how do you get your F tab? F calculated calculated is this one. This is the first f calculated and this is the second f calculated. Then how do you get f tab? F tab is gotten by you comparing f tab of the first one is gotten by you comparing f at the alpha bracket a minus 1 against error a minus 1 b minus 1. So this will be your numerator, while this will be your denominator from your table. So you use what we call f table from your 4-figure table. It's in our 4-figure table. Then we have seen this. Now we go into formula. How do we get SS total? SS total is equal to summation of ij squared minus y squared all over ab. All this alphabet you see us writing is called variable. In the first topic on ANOVA, we say we have to explain some term, and one of the terms we explained was variable. The variable means any quantity that can vary in measurable ways. So this alphabet, you may see it other textbook or other places. It may be another alphabet, maybe X, Y, or KM. Any alphabet can be written here. But what matters there is that whatever alphabet is written here, they must tell you what the alphabet should be used for or what it represents. Okay, we continue. What of SS treatment? SS treatment A or SS factor A. SS treatment A can be called SS factor A. And the formula for it is summation of yi squared all over b. Since here is A, you write b here, minus y squared all over ab. And we now talk the last one. SS treatment B is equal to SS factor B. And it is equals to, that means that SS factor B means equals to summation of yj square all over A, because it is B here, so you say all over A, minus y squared all over AB. Okay? Then SS error is equals to SS total minus SS treatment A minus SS treatment B. Okay? So that is it. So once you have gotten SS total, SS treatment A, SS treatment B, or you know, we say SS treatment A can be called SS factor A, SS treatment B can be called SS factor B. Once you have gotten it, just compute it and get your SS error. Once you have gotten all this, you package it here. Say, okay, what is my MS factor A? MS factor A in my table is equal to SS factor A all over A minus 1. Then MS factor B is equal to SS factor B all over B minus 1. Okay? Then MS error equal to SS error all over A minus 1, B minus 1. So this over this, this over this, this over this, then this divided by this divided by this, you get this. They will give you what your null hypothesis is and what your alternative hypothesis is. So that if you are rejecting null hypothesis, it means you are rejecting this. It means you are rejecting this to accept the alternative. But if you are accepting null hypothesis, it means you are accepting this to reject the alternative hypothesis. So that is all we need to learn on introduction to two-way Anova. Please don't forget to keep in touch with our video so that you see calculation on two-way Anova. See you in next video. Please don't forget to click subscribe and like button as you watch it. See you in the next video.